Hello guys, welcome to our channel Shubhada Group of Education Sirsi. You are watching Satish Sir's physics videos for Karnataka CET and NEET. Look at the next problem on nuclear physics. The following process is known as, so this is the process which is given here. Okay, clearly this is what the pair production. You have already studied the theory regarding the nuclear physics. This is what nothing but this particular the process is belonging to the pair production. So option A is the right answer for this question. Energy in the sun is generated. This must be sun. Okay, sun is generated mainly by clear the fusion of radioactive material, fission of helium atoms and chemical reaction, and fusion of the hydrogen atoms. So it's a theoretical based question, so that's the reason why the energy in the sun is generated mainly by fusion of hydrogen atoms. Option D is the right answer for this question. Okay, look at the next problem here. The half-life period of radium is 1600 years. Okay, so this is what given. The half-life period of radium is 1600 years. The fraction of a sample of radium that would remain after 6400 years will be. Okay, so that fraction that is remaining is n by n naught is the fraction that is remaining. That must be equal to 1 by 2 to the power of t by t naught. That is what t is nothing but how much it is? 6400. 6400 divided by half life is 1600 here. So that's it, it is 1 by 2 to the power of 4. This is what 1 by 16. So 1 by 16 is the right answer. Option D is the right answer for this question. Okay, move to the next problem now. The ratio of half-life time of two elements A and B is Ta divided by Tb. Okay, so Ta by Tb, and the ratio of respect to decay constant lambda A to the lambda B is the question here, right? As you know that the relationship is the half-life T half, that must be equal to natural log of 2 divided by how much? Lambda, right? So this is what we have studied. So therefore I will get lambda is equal to ln 2 divided by how much? T half. Okay, so T half. So therefore lambda A is inversely proportional to what? Half-life, right? Half-life. So that's the reason why we can directly say that lambda A divided by lambda B, that must be equal to TB divided by TA. So TB by TA, that is what option A is the right answer for this question. Okay, move to the next problem here. A radioisotope has a half-life of 5 years. Okay, so the fraction of the atoms of this material that would decay in 15 years will be. Okay, so as the fraction is n divided by n naught, that must be equal to 1 by 2 to the power of t by t half, right? So now t we need to calculate. T half is how much? 5 years. 5 years, correct? So is it correct here? That would remain in 15 years. So sorry, then now t is going to be how much? 1 by 2 to the power of 15 divided by 5, that is what? 1 by 2 to the power of 3, that is what? 1 by 8 is the right answer. 1 by 8. Okay, so 1 by 8 is the right answer for this question. Okay, so but what actually happens is, okay, suppose if you go to the option number A, that is a wrong answer. Even I just got confused here as well. Okay, so the fraction of the atoms of this material that would decay in 15 years, okay, that is remaining ಹೇಳೋದಕ್ಕೂ ಕೂಡ decay ಹೇಳೋದಕ್ಕೂ ಕೂಡ difference ಇರುತ್ತೆ actually. Okay, the fraction of the atoms of this material that would decay, this will give you the fraction which is remaining here. Okay, so therefore the decayed amount is decayed must be equal to how much? 1 minus 1 by 8, that is what? 7 by 8. 7 by 8. Option C is the right answer for this question. Okay, look at the next problem here. The half-life of polonium is 140 days. After how many days 16 gram polonium will be reduced to 1 gram? Okay, so here, okay, so let me use the same relationship, that is what? N by n naught, that must be equal to 1 by 2 to the power of t by t half. Okay, so as you know that the fraction that is remaining is how much? that is what 1 by 16, right? 16 grams. Okay, so after how many days 16 gram per unit will be reduced to 1 gram. Okay, so in the sense 1 by 16, actually it was 16, now it is becoming 1 here. 1 by 16 equal to 1 by 2 to the power of t divided by t half is 140. T divided by 140, correct? So now it implies 1 by 16 is nothing but 1 by 2 to the power of 4, that is equal to 1 by 2 to the power of t divided by 140. So therefore t divided by 140, that is equal to 4 here. So that's the reason why I will get t equal to, so how much it is, 560, right? 560 days. 560 days here. So option C is the right answer for this question. Okay, look at the next problem. After 2 hours, 1/16th of the starting amount of a certain radioactive isotope remained undecayed. Okay, the half-life of the isotope is the question here. Okay, as you know that how to solve this problem, so please try to solve this problem now. So after 2 hours, 1/16th of the starting amount of the certain radioactive is remain undecayed. In the same way, 1 by 16 is remaining, that is equal to, you can say that 1 by 2 to the power of t by t half, right? So now t is nothing but what, 2. So question is to find out the t half now, t half. Okay, so therefore it implies 1 by 2 to the power of 4, that is equal to 1 by 2 to the power of 2 divided by t half. So therefore I will get 4 equal to 2 divided by t half. It implies t half is equal to how much it is, 1 by 2. 1 by 2, 1 by 2 hour, right? So this is what 1 by 2 hours, in the sense it is what, 30 minutes. 30 minutes. So that's the reason why option B is the right answer for this question. B is the right answer. Okay, look at the next problem. The counting rate observed from a radioactive source at t equal to 0 second was 1600 counts per second, and at t equal to 8 seconds it was 100 counts per second. The counting rate observed as counts per second at t equal 6 seconds will be, is the question. See here, so as you know that n equal to n naught, let me take n as the counts now. Okay, n equal to n naught, 1 by 2 to the power of t divided by t half. Clear? So this is what the concept you need to use here. Okay, so as you know that 100 counts, right? So what is that actually? The counting rate observed as t equal to 0 second was 1600 counts per second, and t equal to 8 second it was 100 counts per second, correct? So t equal to 0 it was 1600. Okay, let me take t equal to 8 seconds. At that time initially it was how much, 1600, right? 1600. After 8 seconds it is how much, 100 counts. 100, that is equal to 1 by 2 to the power of, now the question is to find out, they have given the value of t half, t by t half, anything is given, no, right? So that's the reason why I can say after 8 seconds t equal to 8 divided by t half. Okay, so here I will get the value of half period, okay, or the half life here. So therefore I will get to 1 by 16 equal to how much, 1 by 2 to the power of 8 divided by t half, correct? So it implies 1 by 2 to the power of how much it is, 2 3 is 8, 4 is right, 2 to the power of 4 equal to 1 by 2 to the power of 8 divided by t half. Okay, so therefore I will get 4 equal to 8 divided by t half, that is what, t half is going to be how much, 2. t half is going to be 2 counts, right? t half is going to be how much, 2 seconds, sorry, it must be 2 seconds. T is going to be 2 seconds here. Okay, so again at t equal to 6 seconds I need to calculate per counts per at t equal to 6 seconds. At t equal to 6 seconds, okay, what actually happens now here, at t equal to 6 seconds I can say that a equal to, sorry, n equal to, n naught is how much, 1600, right? 1600, 1 by 2 to the power of, now 6 divided by how much, 2, correct. So this is what correct. Now 1600 into 1 by 8. Now 1 by 8, it is what, 200. I will get how much? 200 counts. Option C is the right answer, 200 counts. Okay, so this is how you can solve this problem. So thank you very much for watching this video. Please do like this video, please do share this video with your friends and colleagues to support us. Please do subscribe to our channel. If you have any doubts, make a comment on the comment box so that I can help you with. Wish you all the best for your examinations. Wish you good luck. Thank you. Bye bye.